Happy morning students, welcome to grade 10 mathematics online class. We are dealing with chapter 3 algebra, the last subchapter, that is matrices. The last class just we started with some definitions and I gave some homework problems also. Okay, shall we continue the types of matrices, right? Okay, get ready for the class, take your classwork note and textbook. Okay, check the answers for your homework problems. Listen. Find the order of the following matrices. For the first question, A is equal to 5, 6, minus 1, 2, 0, minus 8. How many rows here? 1, 2. So, 2 rows. The order you have to write first number of rows, then number of columns. Okay. So, here the number of rows is first row, second row. So, 2 rows. 2 rows by how many columns? First column, second column, third column. So 3 columns. The answer is 2 by 3. You should read it by 2 by 3, not 2 into 3. Got it, students? Okay. Now come for the second one. B is equal to 0, 1, 2. It is in column wise order. So here how many rows? This is first row, this is second row, this is third row. So 3 rows and how many columns? Only 1 column. So 3 by 1 matrix. And see this third matrix, that is C matrix. The number of columns and the number of rows are same, correct? This is square matrix. So here how many columns, how many rows? First row, second row. So 2 rows by how many columns? 2 columns. So 2 by 2. Got it, students? Now come for the fourth one. Here the number of columns. Check your answers that you already wrote. So here 1, 2, 3. So 3 rows by how many columns? 1, 2, 3. Here also 3. Got it? Now for the fifth sum, E is equal to 7, 3, 5. So it is in the only one row, the first row. So 1 by 1, 2, 3. 3 columns are there. So here I have to specify the second one. This is column matrix or row matrix. This is column matrix. Since it has only one column, this is column matrix. And this one square matrix because the number of columns and the number of rows are equal. And this is also square matrix. This is of order 2. Square matrix of order 2. This is also square matrix of order 3. Of order 3. This is row matrix because it has only one row and is some more number of columns. So we can consider it by row matrix. Okay, that's all. Check your answers. And the second question, write 5 examples of row, column and square matrices. I think you completed this. Row means like this you need to write. Row matrix here. Like this you need to write. Column means first, second one, no? Like this. And square matrix means like the third and fourth problem. You have to write 5 examples. Got it, students? Shall we move for the next type of matrices? Okay, listen. Listen, dear students, here I wrote the types of matrices. First listen this. The types of matrices, there are 11 types. So first one, row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, zero matrix or null matrix, transpose of a matrix, triangular matrix, equal matrices and negative of a matrix. So first 3 already we learned in the previous classes. Okay, let's recall that. First one, row matrix. Row matrix means how many rows it have? It have only one row. Okay, listen. The examples I wrote. Just listen, okay. The first one, row matrix. Row matrix means it contains only one row. So what's the example? Shall we write one example? A is equal to only one row. It have so many columns. So only one row you should finish. So 1, 3, 5. It has only one row. But number of columns. There are 3 columns. What is the order of this? 1 by 3. Because one row and so many columns. More than one column. Got it, students? So the second one, column matrix. Column matrix means it contains only one column. It may contain more number of rows. Okay. So B is equal to only one column. So first column alone. So 1, 5, 8. It contains only one column and more number of rows. So what is the order of this? How many rows? It have 3 rows and 1 column. So this is the example for column matrix. Got it, students? Okay, then square matrix. Third one, square matrix. Square matrix, what is the meaning? The number of rows and number of columns should be equal. So the condition is number of rows should be equal to number of columns. So it should be in the order 2, order 3, order 4, it may be. Okay, so square matrix, we can write some example. A is equal to order 2 first I will write, okay. Order 2 means 2 by 2. So 6, 5, 4, minus 1. This is of order 2 by 2. This is a square matrix because the number of rows and number of columns are equal. Then B is equal to 3 by 3. 6, 5, minus 1. 6 minus 8, 7, 8, 9, 10. So this is of order 3 because it have 3 rows and 3 columns. Got it, students? So 3 by 3. So first one over, isn't here also? Row matrix over, column matrix over, square matrix over. Then we are going to learn diagonal matrix. Listen carefully. Fourth one, diagonal matrix. So what's the meaning for diagonal matrix? You should check for the diagonal. It should be a square matrix. First, it should be a square matrix. Diagonal matrix are always square matrix. Square matrix, it should be a square matrix. What's the meaning? The number of columns and number of rows should be equal. But the leading element, the leading diagonal element only contain the elements. For example, A is equal to 8, 0, 0, 0, minus 5, 0, 0, 0, 3. So this is a diagonal matrix. The meaning is it should be a square matrix and the leading diagonal only contain the elements, that is diagonal matrix. The diagonal elements only contain the numbers. All other entries are 0, that is diagonal matrix. Got it, students? That means A11 and A22, A33 only containing the elements, that is this is the leading diagonal, principal diagonal. What is the name for this? Except those in the leading diagonal. This is also called as principal diagonal. So this principal diagonal elements only containing number. All other entries should be 0. That is the meaning for diagonal matrix. Okay. Now one more example shall we write? So B is equal to first element A11, A11, A22, A33. The I is equal to J. No. This number, the same number, that numbers are the principal diagonal, otherwise leading diagonal. That elements only containing the numbers. All other entries are 0. That is the meaning for diagonal matrix. So here B is equal to, one more example shall we write? So here B is equal to 5, 0, 0, 0, minus 8, 0, 0, 0, minus 6. So here also check the leading diagonal 5, minus 8 and minus 6. So these elements are the leading elements only containing the numbers. All other entries are 0. So that is the meaning for diagonal matrix. So this one over. Then, so diagonal matrix shall we take? Diagonal matrix. Then scalar matrix. What's the meaning for scalar matrix? It should be a diagonal matrix. So scalar matrix are always diagonal matrix, but the entries should be same. The meaning is A is equal to the leading principal elements, no, the diagonal elements 5, 0, 0, 0, 5, 0, 0, 0, 5. So this is the scalar matrix. What's the difference between diagonal matrix and scalar matrix? In the diagonal matrix, the principal leading elements, that means the A11, A22, A33 containing some elements, different elements. But in scalar matrix, that entry should be same. That is the difference. So scalar matrix, the principal leading elements, no, this one leading diagonal A11, A22, A33 should be equal. That's the meaning for scalar matrix. One more example shall we write? So B is equal to, it should be a square matrix, it should be a diagonal matrix, and the entries should be same. Okay. So 0, 7, 0, 0, 0, 7, 0, 0, 0, 7. So this is also a scalar matrix. This is also diagonal matrix because the principal leading diagonal elements are containing elements, no. So this containing this number, this example, this is a square matrix. Yes, because number of rows and number of columns are equal. Is it a diagonal matrix? Yes, the meaning is A11, A22, A33 containing elements. So this is also a scalar matrix. But listen here, is it a square matrix? Yes, because number of rows and number of columns are equal. Is it a scalar matrix? No. Then meaning is the A11, A22, A33 equal means scalar matrix. Containing some other elements means diagonal matrix. Got it, students? You should clear with the definition. Okay, then scalar matrix over. Now identity matrix. Identity matrix 6. It's also very easy. Identity matrix also a diagonal matrix, but the entries, the principal leading entries are equal to 1. This element, if it is equal to 1 means that is identity matrix. Some other number means scalar matrix. Any number means, different number means diagonal matrix. That's all the difference. Got it, students? So here A11, A22, A33. That means first row, first element. That definition, just wait, that definition I didn't talk, no? So for a general matrix A is equal to, we can denote it by small letters. That means A. First row, first column. That means 1, 1. Okay. Then A, first row, second column. That is 1, 2. Then A, first row, third column. It will goes on like this. Come to the second row, first column. Second row, second column. Second row, third column. It will go like this. This is the general term of the matrix. Okay. We can mention it by A11, A12, A13. What's the meaning for A11? 1 means first row, first column. 1, 2 means first row, second column. 1, 3 means first row, third column. So here, that way I mentioned here, A11, A22, A33 are the principal leading diagonal elements. Leading diagonal. This is the leading diagonal. So in diagonal matrix, the leading elements should containing some entries other than 0. But in scalar matrix, that entry should be equal. 5, 5, 5. Here 7, 7, 7. But in identity matrix, that entry, that means the principal leading element should be equal to 1. That's all the difference. Got it? Okay, now the next one. So scalar over, identity also over. Now zero matrix or null matrix. The another name for zero matrix is null matrix. So 7th one. So null matrix. What's the meaning for null matrix? Null matrix or zero matrix? All the elements should be equal to 0. That is zero matrix. We can denote it by O. So 0, 0, 0, 0, 0, 0. It should not be a square matrix. It may be some other matrix. The order may be different. It have what's the order of this? 2 rows and 3 columns. So all the entries are 0 means that is zero matrix. Then 8th one. Transpose of a matrix. Listen here. Transpose of a matrix. So transpose. Transpose of a matrix. First I am write one matrix. A is equal to 2, 3, 5, 6, 7, 8. So transpose of the matrix means you should write it by A transpose. The power you should mention it by T. Okay, transpose. First, interchanging the rows and columns. First, fix it. This is the row, correct? First row, I am changing the rows into columns and columns into rows. That is the transpose of the matrix. Here the first row, 2, 3, 5 is the first row. And I am changing this row into first column. So 2, 3, 5. Here first row, just I am changed it into first column. So 2, 3, 5 comes like this. Then 6, 7, 8. This is the second row. And I am writing it as the second column. That's all. So interchanging the rows into columns. That is transpose of the matrix. One more example shall we see? So B is equal to 7, 8, 5, 6. So B transpose. How will you write B transpose? What is the first row here? 7, 8. This is the first row. So just to change it into column. So 7, 8. Then second row, that is 5, 6. and I am changing it into second column. So 5, 6. This is transpose of the matrix. And one more time, if you take the transpose, B transpose the whole transpose. What is the answer? Here first row into first column, then second row into second column. You will get the answer of B. So B transpose the whole transpose equal to B. First one we changed. Then again if you take the transpose, you will get the previous answer only. Got it, students? Okay, transpose it, okay? Interchanging the rows into columns. First row I changed into first column. Second row I am changed into second column. That's the meaning. So transpose of the matrix. 8th one also over. Now triangular matrix. Listen here, dear students. Triangular matrix. The meaning is the leading diagonal. This is leading diagonal, correct? This is leading diagonal. The leading diagonal above, that means above the leading diagonal or 0, in which the entry is above the leading diagonal or 0 is called lower triangular matrix. Here, see, in triangle shape, it containing 0, correct? So it is a triangular matrix. So here two types of triangular matrix are there. Lower triangular matrix and upper triangular matrix. Here the entries, numbers are present in lower. So it is lower triangular matrix. So this is lower triangular matrix. Here this is the leading diagonal and this is triangle, and here elements are present in the upper side. This is leading diagonal, this is the triangle shape 0. So here the entries are present in the upper side. So it is upper triangular matrix. Got it, students? Okay, listen carefully. This is triangular matrix. The reason is the leading diagonal element above the entries are 0 means here down only containing elements. So it is lower triangular matrix. Here down the numbers are not present. Up only the numbers are present. So that is upper triangular matrix. That's all. Then 10th one. What is the next matrix? Equal matrices. What's the meaning for equal matrices? Two matrices are said to be equal if their each elements are equal. That means if A is equal to B means, suppose I am writing x 5, 6, 7 equal to 3, y, z, 7. So these two matrices are equal because it containing the symbol equal to sign. So all the entries are equal. So check the first entry. Here what is the first entry? A11. This is A12. This is A21. This is A22. Here also this is A11, A12, A21, A22. So here each entry should be equal. Here what is the first entry? A11. So here x. Here first entry 3. So x equal to 3. Automatically we will get the value. So here 1, 2 means 5. Here y. So y is equal to 5. Then here A21 means 6. Here A21 means z. So z equal to 6. And here automatically 7 equal to 7. So we got the values of this. So two matrices are said to be equal means each corresponding entry should be equal. Here x equal to 3. Y equal to 5. 6 equal to z and 7 equal to 7. That are equal matrices. Got it, students? So 10th one over. Then any more types are there? 10th one, equal matrices. Negative of a matrix. How will you find the negative of a matrix? The last one. So listen. So 11th one. Negative of a matrix. Negative of a matrix. Suppose I am writing A is equal to 7, 2, 5, minus 1. Negative of a matrix means the negative of A is minus A. So each sign you should change. So 7 minus of 7, 2, 5, minus 1. Multiply the minus to all the elements. So what is the answer? Minus 7, minus 2, minus 5 and 1. So that's all. Got it? So A is equal to 7, 2, 5, minus 1. Negative of a matrix means minus A. So minus 7, minus 2, minus 5 and 1, and this is the final answer. So this is negative of a matrix. Got it, students? These are all the types. Shall we revise one more time? So listen carefully. Row matrix contain only one row, column matrix contain only one column. In square matrix, number of rows and number of columns should be equal. Then diagonal matrix in leading diagonal, that means A11, A22, A33 only containing the elements. All the entries are 0. It should be a square matrix. Then scalar matrix, likewise the diagonal matrix, but the leading diagonal should be equal. Then identity matrix, likewise the scalar matrix, but the number equal to 1. Number should be equal to 1. Okay. Then null matrix or zero matrix means all the elements are 0. Transpose of the matrix means interchanging the rows into columns and columns into rows. So here also interchange this row, first row into first column and second row into second column. That is transpose of the matrix. Then triangular matrix. Triangular matrix means above this is the leading diagonal element. Above the element the numbers are 0 and below the numbers are present. So this is lower triangular matrix. Here also comparing with the leading diagonal, down the triangle shape zeros are present and upper one numbers are present. So wherever the numbers are present, you should write as upper triangular matrix. Here also comparing with the leading diagonal, down only the numbers are present. So lower triangular matrix. Then equal matrices means two matrices are said to be equal if each entry should be equal. A11 should be equal to A11. Here A12 equal to A12. Then A21 equal to this and this is also equal to this. That's why we wrote like this. Okay. Then negative of a matrix. What's the meaning of negative of a matrix? You should multiply each term by minus. So negative of A is minus A. So negative of this matrix is each symbol you need to change. You want to multiply it by minus. So minus 7, minus 2, minus 5 and this is plus 1. That's all the types. Shall we move for the example problems now? Okay, listen. Take your textbook and this is the page number 142. So see the first example in matrices, example 3.56. Consider the following information regarding the number of men and women workers in 3 factories 1, 2, 3. So factory 1, the number of men working and the number of women working. Factory 2, the number of men working and number of women working. And likewise the factory 3, the men and women, the number of working persons are mentioned here. Represent the above information in the form of the matrix. So what does the entry in the second row and first column represent? Okay, first we should write in the form of the matrix. So this information we need to mention it in the form of the matrix. Shall we write the answer now? So example 3.56. First as a this is matrix in matrix form. In matrix form, A is equal to. How can we write this one? See the textbook. This one, first row 23, 18. We can write in the first row. So 23, 18. Then second row likewise. Then 15, 16. So that's all. Just we want to mention it in the matrix form. Okay. Then what's the second question they asked? What does the entry in the second row and first column represent? Second row. This is second row. First column represent this one 47. 47 means what is this information? 47 means number of men working in factory 2. That is the answer. What is the first column? First row first column. First row first column means 23 men working in factory 1. Okay. Here they asked what does the entry in the second row first column represent. So second row this one and second row first column means 47. So 47 represents the number of men working in factory 2. So that's the answer. So we should conclude it by the entry in the second row and first column represent that there are how many workers? 47 men workers in factory 2. That's all. Okay. Then example 3.57. Listen carefully. This is also a very important question. If a matrix contains 16 elements, what are the possible orders it have? Okay, we need to write the orders. If a matrix has 16 elements, the solution, number of elements, how many elements? 16 elements. So for example, listen, if a matrix contains number of elements, 4 elements mean what are the possible orders? Number of elements 4 means we can write it by 1, 2, 3, 4. This is also 4 element. This is also 4 element. This is also 4 element. So these 3 ways we can write the 4 elements, correct? Likewise, we can write 4 rows, 1 column, and 1 row, 4 column, and 2 by 2. We can mention the 4 elements in these ways. So what are the possible orders? 1 by 4, 4 by 1, and 2 by 2. So these are the 3 orders if it has number of elements 4. Likewise, we need to write the number of elements is 16 means what are the possible orders. So easily we can find without writing the entries, we can write it simply. Listen. So the possible orders are, in what are the table the 16 will come. So that one if you write means that is the correct order. So first table it will come, correct. So 1 by 16. Then second table will it come? Yes, 2 by 8. Third table will it come? No. Fourth table 4 by 4. Then fifth? No. Sixth? No. Seventh? No. Eighth it will come. 8 by 2. Then again 16 only. So 16 by 1. So the possible orders are, we can write it by 1 row 16 element and 16 rows 1 column, that way. Then 2 by 8, 4 by 4, 8 by 2, and in whatever tables we need to write the factors like this. In first table it will come in 16 times, the second table 8. So if you write like this, you will get the correct order. These are the possible orders. Got it, students? Okay. Mark the homework problems in exercise 3.17. First one, second one, fourth one. Homework. Okay. I will tell the concept outline. Shall I give? Okay, listen. In the matrix A matrix is given. Write the number of elements. So you should count how many elements are there and you should write the answer, the number of elements. Okay. Then order of the matrix. Order of the matrix already you know. How many rows and how many columns. That way you need to write. Then write the elements. A22. A22 means second row, second column. A23 means second row, third column. Then A24 means second row, fourth column. The number present you need to write. So likewise you need to complete this. Okay. Then if a matrix has 18 elements, what are the possible orders it can have? What if it has 6 elements? So 2 questions they asked in one question. First question is 18 elements. 18 elements means you should write like this. 1 into 18, 2 into 9, 3 into 6, like that. 6 elements means what are the possible orders? First table it will come. So 1 into 6. Second table 2 into 3. Then third table. Then sixth table. So that is the answer. So very easy, no? Likewise the example problem, you need to write this. Find the transpose of A. What is the meaning of transpose of A? First row you need to write interchanging the rows and columns. The transpose of the matrix means interchanging the rows and columns. The first row you need to write it as first column. Second row you need to write it as second column. And third row mention it in the third column. That way. Okay, very simple problem. 3 problem. Finish it as a homework. And shall we see one more problem? This problem shall we see. 5th problem. Okay. Listen dear students, 5th problem, A is given, transpose of minus A we need to find. So first minus A we need to find, then only we need to find the transpose. So what is minus A? Negative A. Negative means negative of the A question. Okay. Root 5 to root 3 root 5. Okay. So negative means each value you need to multiply it by minus. So minus root 7, 3, root 5, minus 2, minus root 3 and 5. So negative A over. Then transpose. transpose of minus A. Transpose means first row you want to write it as a first column. This first row I am writing it as a first column. Then second row is second column. Then third row is third column. First row here, second row here, and third row here. Like this third column. So this is the answer. Got it, students? So fifth question over. And the remaining questions we can see in the next class. And before that, complete the homework problems. And the rest we can see in the next class. Thank you, students. Have a nice day.